All right, starting lesson 8.1, simplifying radicals. A perfect square, all right, is a number that can be written as a square of a whole number. So 25 is a perfect square. Why is that? Because we can rewrite it as a whole number squared, 5 squared. So since 25 can be written as a square, it is called a perfect square. To find the square root of a given number means to determine what number times itself results in the given number. So this symbol here indicates that you need to find the square root of a number. Okay, square roots are one type of radical. All right, there's many different types of radicals, and so we're starting off with the most simple radical, which is the square root. So taking the square root of a number means what number times itself is 25, and that's 5. All right, let's do some examples here. Let's first rewrite all these numbers as a perfect square. So rewriting 1 as a perfect square is simply 1 squared. Then we have 2 squared. 9 is 3 squared. 16 is 4 squared. 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. And you should have all these committed to memory. All right, it makes life much easier when you do. Now, the square root of 1 is just simply going backwards. So that's 1. Square root of 4. What times itself is 4? 2. Square root of 9. What times itself is 9? 3. Square root of 16. What times itself is 16? 4. All right, then we just keep going here. All right, simple stuff once you get the hang of it. All right, example 1, simplify. Square root of 81. What times itself is 81? 9. All right, then we have negative 3 times the square root of 25, which is 5. So we multiply these and we get negative 15. Then we have the positive negative of 6 times the square root of 144. Square root of 144 is 12. 6 times 12 is 72. That's positive and negative. All right, and then we have the square root of negative 49. All right, and you cannot take the square root of a negative number. So you just say no real solution. Okay, to simplify the square root of a number that is not a perfect square, you have to apply the what's known as the prime factor tree. All right, a prime number is a number that is only divisible by 1 and itself. All right, with the exception of 1. All right, so examples of primes would be, the first prime is 2. That number is only divisible by 1 and itself. The next prime is 3, then 5, then 7, then 11, then 13, then 17, then 19, then 23, and it keeps going forever. Okay? All right, so example 2, simplify the square root of 20. Now, there is no number times itself that's 20. So what do you do then? Well, what's the smallest prime that goes into 20? The smallest prime that goes into 20 is 2. Now, 2 times what is 20? It'd be 10. All right, now we have a prime here, so we don't touch that prime. 10 is not a prime, so I break it down. What's the smallest prime that goes into 10? 2. I have 2 times 5. Now notice that all the numbers here at the ends of the branches are primes. That's why it's called a prime factor tree. Okay, now once you have this prime factor tree, what do you do next? You look for pairs of numbers, pairs of primes. All right, so here I have a pair of primes. And then here I have this one, this prime just by itself. Now whatever number you have a pair of, that number comes out of the square root. So we pull a 2 out, and if there's no pairs of 5s, so the 5 then stays inside the square root. And that's your final answer. That's how you simplify it. All right, let's do another example. 30. What's the smallest prime that goes into 30? Now always start off with the smallest, all right? Because if you don't, then you're going to have a tree where the branches go all over the place, and you could miss a prime. Smallest prime that goes into 15 is 3. We have 3 times 5. Okay. And notice that there are no pairs. So simplifying the square root of 30, we can't do anything with it. It's just the square root of 30. All right, then we have the square root of 50. We have 2 times 25. And then I have 5 times 5. Now here I have a pair. Here the 2 is left over. Okay, now notice I started with a 5 in the very beginning. So I have a 5. And then now I'm pulling out a 5 because I have a pair of 5s. So you just pulled the number itself out, whatever you have a pair of. And then what's left in the square root? 2. All right, on the outside here I have 5 times 5, which is 25. So my final answer is 25 square root of 2. Let's do a couple more examples. Okay, 72. Smallest prime that goes in there, 2 times 36. All right, now 36 breaks down into 6 times 6, but keeping with the smallest prime rule, I'll do 2 times 18, and then I'll do 2 times 9, and then 3 times 3. Okay, now what do I have a pair of? I have a pair of 2s, and I have a pair of 3s, and I have this 2 left over. So I had a pair of 2s, so I pull out a 2. I have a pair of 3s, so I pull out a 3, and then left over is a 2. So I have 2 times 3 is 6, and then I have square root of 2. All right, 24. I have 2 times 12, 2 times 6, and 2 times 3. All right. Note that I started off with the positive and negative 2 at the very beginning. Now, since I have a pair of 2s, I'm going to pull out a 2. And then I have a 2 left over and a 3 left over. So that stays inside of the square root. So positive negative 4, square root of 6. Done. All right, for the next one I have 2 times 40, 2 times 20, 2 times 10, and 2 times 5. All right, I have 1 pair of 2s. I have another pair of 2s. Okay, so I have 1 pair of 2s, so I pull out a 2. I have a second pair of 2s, so I pull out another 2. And I'm left over with the 5 inside the square root. Simplifying that, I get 4 square root of 5. Done. All right, 2 more examples. Let's see here. I'm taking the square root of a negative number. You can't do that, so there is no real solution. Okay? And same thing for the next one. No real solution. You cannot take the square root of a negative number. All right, we're done. All right, begin the assignment.